In today's world, people turn to the internet to share and express their thoughts on a multitude of topics. Creating an engine to crawl the internet and go through such a process where the information is validated, weighed, categorized, and in such a manner that can later be understood by the end user is critical to utilizing this information to the fullest. Our proposal for an AI that is capable of this will address how the engine will crawl the internet, the architecture of the AI itself, and the challenges and costs of implementing such an AI.
Before talking about the algorithms, we should first know how people express their moods and emotions and convert their feelings in words. Knowing the science will help us develop algorithms to detect people's feelings. Here we listed some of the common ways that people generally use in writing, especially in social media, to express their emotions. The first and the most obvious ones are the mood words. Words such as love, disgust, angry, etc., can clearly show writer's intent. The second way would be words describing reactions and behaviors related to emotions. When we say, the boy cried when he saw his mother, we depict the mood of the boy by using the word cry. Using superlatives like best or worst also can show emotions. Intensifiers such as really, awfully, never may also help us to find emotions as well. When we say, I will never go to this restaurant again, we are indirectly showing our negative feeling towards restaurants. Finally, pejorative and laudatory words and phrases, and of course curses and swearings, can also be used to understand one's feelings. In the simplest form, the task of the algorithms would be to detect these phrases and use them to obtain the opinions of people towards a subject. An opinion consists of 5 components. First, there is target entity and the target aspect of entity on which the opinion has been expressed. Then we have sentiment of the opinion, and finally, we have opinion holder and opinion posting time. Let's clear it with an example. Let's assume we are interested in knowing the proportion of votes of American citizens 1 month before 2016 presidential election. The target entity in this example will be 2016 US presidential election, and the target aspect of entity would be the candidates, which were Hillary Clinton and Donald Trump at the time. Sentiment of the opinion in this example can be how left or right-leaning the candidates are, and citizens of the United States will be the opinion holders. 1 month's period left to the election will be the posting time in this example. It should be noted that not in all cases we have all 5 components of an opinion. In short, the process of data crawling can be summarized in 4 steps. First, we should choose a source of data or a combination of sources of data. Depending on the purpose of the project, sources can range from reviews of a product on Amazon to news articles in New York Times. The data collected then needs to be anonymized and secured before going to the next level. Third-party data management services help us to do so. Data needs to be cleaned next, so that incomplete or corrupted data will be removed. As in most cases, the size of the data is so huge, a sample of data is selected to reduce the cost and computation time. One of the applications of sentiment analysis is in analyzing the results of election. By observing trends in social media, we can know, for instance, the effect of debates or speeches of candidates on public opinion. The first step is to extract data from social media like Twitter or other third-party apps that crawl social media. Next, we need to tokenize the data. Not all the information on the media are words, so we need to handle URLs, emoticons, repetition of symbols by using a tokenizer. The next step would be to refer content to candidates. For instance, we can create a set of keywords for each candidate based on their names and campaign. Using the data, sentiment model can now be developed. Part of the data would be first judged by humans to decide whether they are positive, negative, neutral, or maybe both positive and negative. Various models, such as naive Bayes and unigram feature, can be used to train the algorithm. Finally, the data will be aggregated and will be used for visualization. Of course, there are challenges in such methods for analyzing social media data. Language used on the internet, especially social medias, are different from formal written or even spoken languages. They often contain internet slangs, sarcasms, and acronyms specific to internet. Also, these types of analysis are biased to people who use internet, which tend to be younger and more affluent than general public on average. The other challenge are hackers and even governments who try to manipulate the results of elections by using fake accounts. Different actions should also be given different weights. For instance, an opinion expressed by a journalist should have a bigger impact on the model than a retweet by an anonymous user. And finally, sometimes it is hard to validate the results of such models. For instance, we may have to wait till after the election to see how good our model performed, which may be too late in most cases.
Our framework is a four-step end-to-end process. First, we perform data crawling over news sites, social media, videos, and tweets to obtain information about the opinion source. Second, we perform feature extraction on the data for the important variables that we need. For example, subtitles, sentences, captions from text documents, and video description. We extract metadata from the source, for example, shares, likes, dislikes, view count, number of comments, and location. We also extract search engine statistics for additional information, such as page count, hits, and trends. For text data, we perform feature processing to vectorize words into numerical values. Lastly, we use machine learning and generative modeling techniques for sentiment analysis. The key idea of using generative modeling in our machine learning architecture is that we learn from data to uncover latent representation about the opinion. For example, whether or not the opinion is positive or negative, and how strong this sentiment is. Next, in the training phase, we use a risk minimization technique that is similar to economic behavior theory. The mathematical equivalent is that of variational inference learning. Using this objective function, we then update our model parameters to minimize the error between the generated and training data. The next step is prediction. In this phase, we take the trained model to perform structured output classification. We use a semi-supervised unimodal classifier on the output, which is suitable for our task. Next, we score the sentiment on the opinion according to a rank scale. We predict the score, and each piece of evidence is given a ranking from 1 to 10. Our proposed machine learning architecture is based on Bayesian variational inference, which is one of the most used optimization tools in machine learning. The exponential growth of scientific articles and applications using variational inference shows its importance. In real-world applications, it has been successfully used on recommender systems such as movie ratings and e-commerce. Our strategy for the task is the following. We use generative modeling to create a scoring system that provides a credibility score for each piece of opinion or news article. This can be further characterized into score indicators to provide more accurate classification. As an alternative, we could also combine human knowledge with machine learning. This is to provide fair and unbiased judgment, and we can allow humans to intervene to exercise discretion for additional consistency. Lastly, we can also adapt for different opinion types across news articles.
In terms of a per employee basis, there would be around $7,000 a year for IT costs, which include costs such as the computer for the employee, phones, tablets, the voice and data network, an IT service desk if there would be need, and standard applications such as Microsoft Office. Beyond this, there are also paid development tools that the developers may choose to use for the creation of this project. These are not necessary as there are open source options, however, it is common that companies do turn towards paid development tools. Open source tools that can be of a great help towards this, such as TensorFlow and Common Crawl, may be used. This may not be implemented, but however, for internal testing purposes, these are great resources for the company to turn to instead of using only paid options. In terms of enterprise costs, $350,000 a year would be allocated in general IT costs, which include the data center, which has mainframe servers and general storage for the organization, internet services, and upkeep costs. $5,000 a year would be included for cybersecurity license for only 1 year, but any additional security beyond this would have to have additional funds. Servers, such as using AWS or having an in-house server, have two different types of costs. For in-house, it would be around $14,000 a year, but for Amazon Web Services, it would cost depending on the resources used and the package that is chosen based on the organization's needs. Artificial intelligence has a great influence on the digital economy. There are many sectors that it impacts, such as transportation, finance, research and development, e-commerce, and in general, big data. There is great economic impact with artificial intelligence and what it is capable of, and there would be great investment opportunities for people interested in utilizing such an algorithm to be able to then extract data from the internet for the purpose of benefiting their own businesses or endeavors. In conclusion, our algorithm will address detecting deceptive opinions, have a large number of diverse sources, use analysis techniques that are both popular in academia and in the industry, as well as having a positive economic impact. This algorithm can be used in future trends. It can be incorporated into users' social circles and geographic locations to provide relevant suggestions. It also adheres to the General Data Protection Regulation, so it will not disclose individuals' specific opinions, but has them anonymized. Also, this can influence policymaking and justice systems, as it can provide relevant and accurate opinions of individuals who live in a certain geographic area.